The appliance repair technician who charges you $285 just to pull into your driveway knows exactly what you are about to learn. They use this exact 15-minute protocol before every single diagnostic job. Then they reinstall the access panel, hand you an invoice, or tell you it is time to upgrade to a premium smart model. If they told you to buy the $5 tool yourself, their entire business model collapses overnight. They are not going to tell you. Every major appliance you have ever replaced for failing to cool was designed to attack your wallet through engineered ignorance. You were never buying a bad brand. You were buying into an artificially shortened life cycle. This is not a proprietary Freon recharge kit. This is not a diagnostic motherboard bypass. This is not a temporary surface treatment. It is the fundamental physics of thermodynamics applied at the physical level. The manufacturers did not hide this maintenance requirement because it failed. They stopped talking about it because it worked too well. Heat cannot be destroyed. It can only be moved. 3 completely isolated civilizations with zero contact between them, separated by thousands of years and entire oceans, all independently discovered the exact same principles of thermal displacement. That is not coincidence. That is not folklore. That is physics patiently waiting to be understood. In 400 BC, the engineers of ancient Persia constructed the Yakshal in the middle of the desert. These massive, conical evaporative coolers maintained ice through the blistering summer. They did not achieve this with magic. An artisan named Cyrus documented the precise airflow channels required at the base to draw in subterranean cool air, displacing the rising heat through a precise exhaust hole at the apex. If the vents choked with sand, the ice melted. The system required absolute, unobstructed airflow. In the 3rd century BC, during the Han Dynasty in China, royal engineers deployed the Binjian, a sophisticated double-walled bronze ice cooler. They realized that the efficiency of the cooling relied entirely on the thermal conductivity of the bronze separating the ice from the food. If the bronze oxidized heavily or was covered in insulating soot, the heat transfer stopped. The food rotted. By the 1st century AD, Roman engineers under Emperor Nero built massive insulated ice pits on the slopes of Mount Alban. They utilized layers of compressed straw and ash to seal the cold air inside. If a single gap formed in the straw seal, the ambient Roman summer rushed in. The thermal barrier was compromised. Every civilization with ambient heat and a need for preservation arrived at the same conclusion independently. Cooling requires unobstructed thermal transfer and an absolute atmospheric seal. If either is compromised, the system fails. The modern refrigerator is not a magic box that creates cold. It is a heat pump. In 1834, an American inventor named Jacob Perkins built the world's first working vapor compression refrigeration system. He understood that when a liquid evaporates into a gas, it absorbs heat. When it condenses back into a liquid, it releases that heat. Your refrigerator uses a compressor to squeeze a refrigerant gas, raising its temperature and pressure. This blistering hot gas travels through the condenser coils, the black tubes traditionally mounted on the back of the fridge. Here, the heat is released into your kitchen. The cooled liquid then flows into the evaporator coils inside the freezer, absorbing the heat from your groceries, and the cycle repeats. The entire system is governed by Fourier's law of thermal conduction, expressed formally in heat exchanger design as QUA upon delta T, where Q is the heat transfer rate, U is the overall heat transfer coefficient, A is the surface area, and delta T is the temperature difference. The U variable is the target. The condenser coils are engineered to transfer heat to the surrounding air. But when those coils become coated in a 3 mm layer of pet hair, dust, and cooking grease, that coating acts as a thermal blanket. The U plummets. The heat cannot escape. The compressor must now run constantly. The internal temperature rises. The mechanical stress skyrockets. The system eventually seizes. A landmark 2006 peer-reviewed study published by the American Society of Heating, Refrigerating, and Air Conditioning Engineers investigated condenser fouling. The findings were quantified and definitive. A heavily fouled condenser coil reduces cooling capacity by 30% and increases the compressor's energy consumption by up to 20%. The U.S. Department of Energy explicitly confirmed these thermodynamics in their appliance efficiency protocols. The dust insulates, the heat traps, the compressor burns out, the organism ceases to exist. The global household appliance market generates $120 billion in annual revenue. The appliance repair subsector generates another $5 billion in North America alone. They do not want your refrigerator to last 25 years. They want it to last 6. Follow the money. That is always the answer. In the 1980s, the average lifespan of a standard domestic refrigerator was over 2 decades. The condenser coils were mounted on the back. They were visible. When they got dusty, your grandmother wiped them down with a rag. The heat transferred perfectly. The appliance lived forever. This was an economic disaster for the manufacturing sector. You cannot sustain a $120 billion industry on a product that never dies. You cannot patent basic thermal maintenance because it is a law of nature. So, the industry quietly executed a design pivot under the guise of aesthetic improvement. They moved the condenser coils from the accessible back of the unit to the dark, inaccessible bottom. They covered them with a plastic kick plate. They placed them millimeters from the floor, exactly where pet hair, dust mites, and debris accumulate the most. Then, they engineered a secondary psychological trap. They stopped printing maintenance instructions on the front of the unit. They buried the coil cleaning requirement on page 42 of the user manual, a document they knew 95% of consumers would throw away. They began marketing these units as maintenance-free. It is a subscription disguised as a product. When your modern bottom coil refrigerator stops cooling, you assume it is broken. You call a professional. The professional pulls off the kick plate, takes a $5 nylon coil brush and a shop vacuum, and removes the thermal blanket of dust. They reset the defrost timer. The physics immediately corrects itself. The fridge drops to 37 Fahrenheit. Then, they hand you a bill for $285 for a system diagnostic and thermal calibration. Or worse, they tell you the compressor is strained, the repair will cost $800, and you are better off buying a new $2,000 unit. That is, $120 billion flowing from homeowners to corporate manufacturers every single year because of engineered thermal suffocation alone. They did not ban the $5 nylon brush. They simply removed it from every shelf, every guide, and every conversation. This mechanism of engineered failure is not isolated to refrigeration. The appliance industry has weaponized fundamental physics against you in almost every machine you own. We have documented the blueprints, the washer-bearing betrayal, why a $2 part destroys a $1,000 machine, the dishwasher heating element lie, the calcium threshold they never disclose, the HVAC capacitor ransom, the $15 cylinder your technician charges $400 to replace, the oven igniter illusion, the artificial resistance curve, the water heater anode rod clock, how they guarantee a rusted tank in exactly 72 months. Links to these guides are in the description. But stay here. The science behind what you are about to do to your refrigerator is about to make the appliance manufacturing sector very uncomfortable. Before you bypass the repair industry, you must understand the physical limits of this intervention. This protocol restores thermal transfer and atmospheric seals. It does not resurrect dead mechanics. The start relay click, if your refrigerator is warm and you hear a distinct loud click coming from the back every 3 to 5 minutes, followed by silence. The compressor's start relay or the compressor itself has failed mechanically. Brushing the coils will not fix a seized motor. The sweet smell of death. If your fridge stops cooling and you detect a faint sweet chemical odor inside the cabin, you have a sealed system freon leak. The thermodynamic fluid is gone. A professional with a brazing torch and EPA-regulated refrigerant is legally required. The electrocution hazard, you must unplug the machine before opening the back panel. Refrigerator capacitors hold a lethal electrical charge even after the motor stops. Never touch the exposed wiring harnesses near the compressor block. An improper ground can stop a human heart. This is a physical reality, documented in occupational safety reports. Disconnect the power completely. If you lack basic mobility to access the floor, or if your built-in unit is structurally integrated into custom cabinetry and cannot be rolled forward, you must call a technician. But for the 90% of freestanding refrigerators prematurely sent to the landfill, proceed to the sequence. Go to any hardware store. Buy a long, flexible nylon condenser coil brush. It will cost exactly $5 to $8. Procure a standard vacuum cleaner with a hose attachment. Boil a small kettle of water. Follow this sequence exactly. STEP1, the thermal excavation. Unplug the refrigerator. Remove the plastic kick plate at the bottom front of the unit. It usually snaps off with gentle pulling. Shine a flashlight underneath. You will see a dense, felt-like wall of gray dust blocking the condenser coils. Insert the flexible nylon brush deep into the coils. Twist and pull. Extract the dust. Vacuum the debris simultaneously. Continue until the coils are visible, black, and completely clear of obstruction. STEP2, the dollar bill gasket test. Open the refrigerator door. Place a crisp $1 bill halfway inside the cabin and close the door on it. Pull the bill out. You should feel distinct physical resistance. If the bill slides out effortlessly, the magnetic rubber door gasket has failed. The Roman thermal seal is broken. The cold air is falling out onto your floor, forcing the compressor to run 100% of the time. Order a replacement gasket online for $40. It presses into a groove by hand. No tools required. Step 3. The defrost drain flush. If water is pooling under your crisper drawers or leaking onto the floor, the internal defrost drain tube is clogged with bacterial slime or a frozen block of ice. Locate the drain hole at the bottom back wall of the fridge or freezer compartment. Slowly pour 1 cup of boiling water directly into the hole. The hot water melts the ice blockage and dissolves the biofilm at the molecular level. Listen for the water to hit the drain pan underneath the unit. The leak is permanently solved. Step 4. The damper on blocking. If your freezer is perfectly cold, but the refrigerator section is 55 degrees Celsius and spoiling milk, locate the air vents in the wall dividing the 2 compartments. This is the damper. Cold air is manufactured only in the freezer. A small fan blows it through these vents into the fridge. If you have jammed a large box of frozen food directly against these vents, you have stopped the airflow. Move the boxes. Establish a 2-inch clearance around all internal vents. STEP 5. The condenser fan verification. While the unit is still unplugged, roll it forward. Remove the cardboard or metal lower back panel. Locate the condenser fan sitting next to the black football-shaped compressor. Spin the plastic fan blade with your finger. It must spin freely. If it is jammed by a stray piece of paper or binding from dust, the compressor will overheat in exactly 45 minutes and shut down. Clear the obstruction. Consider David, a high school teacher in Columbus, Ohio. In November 2023, his 5-year-old Samsung French door refrigerator stopped cooling. The internal temperature read 62 Ref. The compressor ran loudly and continuously. A local authorized repair service quoted him $120 for the diagnostic and estimated a $900 compressor replacement. They strongly advised him to visit their showroom to buy a new $2,400 model. David declined. He executed steps 1 and 5. He found a massive layer of golden retriever hair completely suffocating the bottom condenser coils and a piece of plastic wrap jamming the condenser fan. He spent $6 on a brush. He cleared the blockage. He plugged the unit back in. Within 4 hours, the temperature stabilized at a perfect 37°F in the fridge and 0°F in the freezer. The compressor hummed quietly. The repair took 12 minutes. The total cost was $6. He kept his $2,400. The Persian engineers knew it. The Oshry physicists confirmed it. The $120 billion appliance industry spent millions in marketing and design, making sure you never did. They prayed you would just assume the machine was dead. They relied on your exhaustion to drive you back to the big box store. But now you see the architecture of the trap. If you have made it this far, you already know more about appliance thermodynamics than 99% of modern homeowners. You possess the permanent, unpatentable solution. Every share puts a crack in the wall they spent billions building around knowledge that was never theirs to lock away. Every subscription keeps this channel digging where they do not want us to look. Do not let this knowledge die in your algorithm. Send this to someone who owns a home. The next vault opens soon, and what the residential plumbing industry buried inside that one is even heavier than what you heard today. Do not replace it. Fix it.